Hi, I'm Chris Mattson, Faculty Director of the Design Exploration Research Group at Brigham Young University. I'm here to describe to you some of the projects that our students worked on last semester. We had a small group of students, 5 students, that designed, built, and tested this structure that you see behind me.
According to the UN, over 1 billion people in the world have inadequate housing, and over 100 million people have no housing at all. In this project, we were able to take that challenge and turn it into an opportunity where we could design a structure that would be easy to assemble, have very few parts, be affordable, compact, and weather resistant, but most importantly be strong, durable, and well engineered so that all we would have to do is ship it over, have them carry it in on a very low-cost cart, assemble it, and have a structure that they could rely on and count on as their home for as long as they needed it.
One of the real benefits with these structural elements that we have is these midline cuts here. If we flip the element over from those midline cuts and we begin folding, it's pretty simple to get a good structure here. And by just using these pins, we can insert them through 2 holes that have been milled into these panels and make a solid beam out of a flat panel.
If I want to build a house in the United States, I'll use a big pile of 2x4s, a big pile of 2x6s, a big pile of 2x10s. In addition to that, subflooring, sheetrock, all these different kinds of elements. Now you might add up all those elements and find that there are only, say, 20 or 30 different kinds of elements. But under typical construction in the United States, almost every one of these pieces will be custom cut to a certain length, which means in the end you have many, many, many different types of elements going into a structure for the United States. What you see behind me in this structure is just 5 elements plus a connector. And these 5 elements all come from one sheet of raw stock, which is the 4x8 sheet of the polypropylene.
If you look at the house behind you and some of the other shots, you'll see there's kind of 2 modules, and so one module costs about $650. It also takes about a day. It took us as a team about 8 hours to assemble the whole house. Manufacturing time took considerably longer, but as for plain ground to a full structure, it was about 8 to 10 hours. From our preliminary numbers, in an 8x8 by 40-foot cargo container, which is fairly standard size, we can fit about 32 of these homes. All the panels, all the connectors needed for the entire structure that you see behind us. The polypropylene has really good resistance against corrosion and deterioration. As we know, plywood, if it's left in the ground or outside for a long extended period of time, can get waterlogged, deteriorate, and start to rot, especially in warm environments. This polypropylene is built and sold actually as signboard material, so it's meant and designed to be in the weather, out there for long periods of time. That material, along with the structural qualities inherent with the thick corrugation, really made it a perfect material for us. We took a couple of different approaches to ensure that we had a structure that not only looked good on paper and in CAD, but also was a viable structure in real life. So we started with FEA analysis, and we actually have Pasha, who has a lot of experience with FEA and writing specific FEA scripts. He was able to take this structure and to analyze the wind loads on it, to analyze a lot of the beams in it.
While it's important for us to consider the finite element analysis, it's even more important for us to look at some extreme situations. What happens when someone hangs from the rafters? What happens when someone climbs up on the roof and walks around? What happens when someone's playing a game of football and runs right into the structure? These are the kinds of things that we want to be aware of. We want to be able to make sure we can build a structure, design a structure that can withstand that sort of abuse. I'm very proud of what the team has been able to do, especially in the short time period that they've had to work on the project. It's just a prototype, but we're on our way to getting something that would be really, really quite cool.